All right, the area of a parallelogram. So if you watched the last video, we talked about area kind of in general terms, though the example that we did use was a rectangle, so a type of parallelogram. And what we said in that video was that we talked about finding the area of a figure kind of by sectioning it off, right? How far is this? We talked about two important concepts. How far is it across? And how far is it up and down? Now, as you might notice here with the parallelogram, as we've drawn it, that time it was a rectangle. In this video, we're talking about any parallelogram. I don't care what it is. Rectangle, square, rhombus, just a general parallelogram. How do I find its area? I would also like to do this with a formula. I don't want to have to draw out the lines and section off the parallelogram each time like we did in the last video. I want to do it a little bit more straightforward. I'd like to use some math. So, you may remember this idea, this formula. The area of a parallelogram is exactly the base of that parallelogram, the distance across, by its height, the distance up and down. We know that formula, right? There's one important thing that you need to notice here. Look at the yellow lines as compared to the white ones. The distance across is exactly the bottom of that parallelogram, segment DC. Also segment AB, we know that opposite sides in a parallelogram are congruent. However, look at the difference between BC, the segment of the parallelogram, and that yellow up, the height. You should notice, of course, that BC is slanted and H is straight up and down. So this brings us to an important fact. Whenever, and again, I don't care what figure we're talking about, base and height will apply in certain ways to any figure, whether a quadrilateral, pentagon, hexagon, octagon, and so on. Base must be perpendicular to height. Always. Base must always be perpendicular to height. So, let's use this. Let's do some practice. Find the area. One thing just to be aware of when you're doing this, sometimes they give you the base and the height as they have here in our first example. That base is only this much. You got to be careful of that just to make sure that, for example, they didn't decide to trick you and give you both the solid line for the figure and the dotted line that forms that right triangle. Why do I have that going on out there? Simply because, again, I need the height of the figure. I need something to be perpendicular to my base of 3. And I draw it in such a way coming from the top of the figure straight down. And I do kind of extend that base out a little bit using a dotted line to show that I'm just connecting it for purposes to show that it is perpendicular, but I'm not in any way extending the side of the figure at all. Alright, so 5 is the height and 3 is the base. So if I want to use my area formula, I'm going to say that area is equal to the height 5 times the base 3, 15. And let's say this is in feet, so area would be in square feet. And that's it. So then, let's try the other one. Well, I definitely have a base of, let's say this is in meters, of 4. And I have a side of 5, but I don't have a height. I need to find it. Well, what do I know? This is a parallelogram. Opposite sides are congruent. So that is also a 5. Oh, look. I have sides in a right triangle. 5, the hypotenuse squared, should be equal to 2 squared plus h squared. So 25 equals 4 plus h squared. 21 equals h squared, taking a square root on each side. And the square root of 21 is about 4.58. And now I can do the area. My base of 4 times my height of 4.58 is about 18.33. We are measuring in meters, so this would be meters squared. All right, you do this part, hit pause and hit play when you're ready. All right, in the first one, they give us that the height and base are there, 5 and 6. Multiply them together, we get 30. They didn't give us units here, so I guess you could write like units squared. Otherwise, you could just say 30. 7 times 4 for the second one. We see that the base is 7. We need to find the height, h. Using the Pythagorean theorem, we would see that we have a 3, 4, 5 right triangle, 4 being the height. 7 times 4, which is 28. Again, remember that we know the base is 7 because EF and GH are congruent. Actually, now that I look at it, that G really should be over there. All right. I've given us some problems here that are not quite what you might expect. Find h if, and they give us that rectangle. Well, I know the base is 15. I know the area is 60 feet squared. So if I would like to find the h, the height, starting with my formula, area equals base times height. Well, the area is 60, the base is 15, the height is h. Divide by 15 on each side, and 4, actually let me back that up, 4 feet equals h. All right. Find b if, well, that's the height, and that's the base. So the area 120 equals the base b times the height 5. Divide by 5, and b equals 24 meters. And then the last thing before we close, area of special parallelograms. Rectangle, we have the formula that many of you probably learned in grade school. Rectangle area is length times width. Of course, L is length, and W is width. Square is S squared. S is the side, right? Length. Why is it side squared? Well, in a square, of course, we know that all sides are congruent, making the base and the height the same number. Also, we know that's the case because in a square, as well as a rectangle, they are automatically the sides of the figure. If base and height are perpendicular, we know that in a rectangle and a square, the sides are perpendicular. We simply have the sides of the figure there. And then finally, the rhombus, we have 1/2 diagonal 1 times diagonal 2. We'll talk about that in a different video. Thanks for watching.